Hello class, today we're going to talk about area and all the area formulas that we're supposed to know in the 7th grade. You'll notice on the opening screen here we've got several different shapes, and those are the ones that we're supposed to know about. We need to know about a rectangle. We need to know about a parallelogram. We need to know about triangles. We need to know about circles, and we need to know about trapezoids, which is what's on the bottom. It says trapezium, but it's just a trapezoid. So one of the things that we do have available to us is we have our formula chart, and this is the 8th grade STAAR materials reference chart. Okay, and it's got a bunch of things on it, but if you'll notice down in this middle section right here, this is the section that we're focusing on in this series of lessons. Okay, so let's see if we can zoom into that. You'll notice we've got several things here. We've got circumference of a circle, and we have two formulas. We have circumference is equal to 2 pi r, and we have circumference is equal to pi times d. Now what we have to understand about this is two things. Okay, circumference is the same thing as perimeter in a polygon. It's just the distance around the shape. So in a circle, well, since it's not a polygon, we can't call it perimeter. So we call it circumference. And we need to understand pi. Pi, the value that we will use typically, is going to be 3.14. Okay, so that's the first 3 digits of pi. Pi is just a ratio that we use in circles. It's the ratio of the distance around the circle divided by the distance across the circle. The other things that we need to know, excuse me, is we need to know what the r stands for. The r is equal to radius. Okay, and then the d in this formula is equal to diameter. Now, what do those look like? Okay, well, if you have a circle, okay, the distance from the center to the circle itself is the radius. That is always our radius. It is halfway across the circle. And if I have 2 radii put together that go through the diameter, okay, or through the center, excuse me, that is known as the diameter. So those are the things I'm looking for. So if I'm given halfway across, that's the radius. And if I'm given all the way across, that's the diameter. Okay, now, I need you to understand something in the lessons that I'm going to teach. I do not use c is equal to 2 pi r. I don't use that formula. I always use circumference is equal to pi times diameter. And the reason why is because when I was a kid, I always got the circumference formula and the area formula mixed up. I never knew when it was 2r, and I never knew when it was r squared. So what I had to start doing was for circumference, I would only use the pi times diameter formula. So that told me that when I had the radius formula, that was the formula for area. Okay, so I'm only going to use c is equal to pi times diameter. Now we have a triangle, and we're looking for the area of a triangle. And area is defined as the space on the inside of a 2-dimensional object. Okay, so for a triangle, we have a formula that's a is equal to 1/2 bh. Now the formula that I will typically use is going to be BH divided by 2, okay, because I know that 1/2 of something is just divide by 2. A rectangle and a parallelogram have the same formula. Area is equal to base times height. Now for the trapezoid, I'll do the same thing that I did for a triangle. When I see this 1/2, that means I'm going to divide it by 2. So the formula that I will use is a is equal to b1 plus b2, which stands for the 2 bases, times the height, divided by 2. And then of course we have the area formula for a circle. So what this lesson is going to be about is how do I use each one of these formulas to solve a math problem. Okay, so let's start off by looking at a compound figure. The only time we ever typically use a rectangle is if it is in conjunction with something else. So in this particular problem it says how many square feet of siding does a builder need to cover the side of the house shown at the left? Okay, so if you look at this figure, okay, it's actually at the right here on this particular page. Okay, so if you look at this particular thing, we've got 2 shapes. This house is divided up into 2 parts, okay, because originally it's just a pentagon. It's a 5-sided shape. So we've got a rectangle at the bottom, and we've got a triangle at the top. So what we have to do is we've got to find the area of both of those, and then add those areas together. So we'll start with the bottom, with the rectangle. So I would like for you to always start by writing down the formula. Area is equal to base times height. Now the way you can always recognize a base and a height is it's going to be touched by a right angle. The base and the height will always be touched by a right angle. Now the base, the majority of the time, it's going to be a solid figure. It will be a figure that is part of the shape. Okay, we'll understand that when we get to triangles. The height, sometimes it will be part of the shape and sometimes it will be a dotted line distance. Okay, so let's see if we can do this. We're finding the rectangle. So I know my base is 16, my height is 10. So I will just do 16 times 10. So my area is equal to 160 feet squared. Okay, now I have a triangle. So I write its formula down. Base times height divided by 2. So area is equal to, well, our base in this particular triangle, well, it's the same as the base on the rectangle. So it's 16 times, well, how tall is it? Well, here you'll notice that height is represented by a dotted line because the height is defined as the perpendicular distance from the base to the point farthest away from the base. So that's why we are provided that on the inside of the figure, but it's not actually in the figure itself. It's not an actual measurement of the figure. Okay, so we know our height is 9, and then we're going to divide that by 2. So now we take our calculator or any other device, and you would multiply 16 times 9 and divide that by 2. Or you could, if you didn't have a calculator, you could do some simplifying. That would turn into a 1, and that would turn into an 8, and we end up with 72 feet squared. Now to find the total area, we take those two numbers and we add them together. So we would do 160 plus 72, and that would be equal to, and you go add it up, and you find out that it's 232 feet squared. And that's how you find the area of a composite figure. Okay, so we divide it up into shapes that we know, and we find their areas. So now let's look at just a triangle. Okay, now this time what I'd also like to do is look at perimeter, because a polygon does have perimeter. And on your assignment that you'll have, you will need to do both. Okay, so the first thing we look at is let's find perimeter. Perimeter is defined as the distance around the shape. So you start at one spot and you walk around it. And you add up those pieces. So we've got a 5 and a 5 and an 8. So we end up with 18 centimeters. And perimeter is a single measurement. It is a distance. So it does not get a centimeter squared or cubed or anything like that. It is just a linear measurement, centimeters. All right? So now for area, we now write our formula down. So A is equal to, and for a triangle, it's base times height divided by 2, or 1/2 base times height. So we plug in our information. Okay, so I go find my base and my height, and again, the base and the height are touched by a right angle. So my base is 8, my height is 3, and I'm going to divide that by 2. So the area of my triangle then is 8 times 3 is 24, divided by 2 is 12, and in this case, centimeters squared. So 12 centimeters squared. Okay, now it's centimeters squared because it is a two-dimensional measurement. Okay, and that's what the 2 stands for. Perimeter is a one-dimensional measurement, so it's centimeters to the first, or put nothing there. Area is centimeters squared because it is a two-dimensional measurement. And that's all there is for triangles. Find the base, find the height. I know they're both going to be touched by the right angle. And then you multiply those together and divide it by 2. Because if I don't divide by 2, I actually get the rectangle that surrounds it. Okay, so that's what we do. So let's look at another interesting triangle here. It says, what if you were given the area and asked to find one of the missing parts? Well, in this formula for a triangle, that's A is equal to BH over 2. We have 3 variables, 3 things that I can plug in. I can plug in an area, I can plug in a base, and I can plug in a height. Okay, so I can plug in any one of those. So this problem first asks, do I know the area of the figure? And I do. Okay, so I'm going to plug that in, 216 equals. And we can know that this is an area, this 216 is an area because of 2 reasons. 1, it tells us that it's an area, but 2, our label is unit squared, yards squared. That is a label of an area. So 216 equals. Now do I know my base? Well, this right here is part of the figure. It is a solid line. It's our 24. That is our base. And you'll notice we provide an extension out here because this height, I cannot draw a vertical line anywhere from this base and touch the furthest point away from it. So that's why we provide this extension. And what I'm looking for is the h. And now all we have to do is use our algebra to solve. So we start by getting rid of the divide by 2. We do that by doing a multiply by 2. And if I do it to one side, I have to do it to the other. And I end up with 432 is equal to, and these 2's go away, 24h. Then I divide both sides by 24. And h is equal to, or the height is equal to, 432 divided by 24. And you end up with 18. And in this case, it would be 18 yards. Okay, so sometimes you'll be given an area and have to work it backwards. Okay, so just understand that. In the formula that we use, it's just an algebra problem. So once you plug in the information, you use your algebra to solve what you don't know. Okay, we've got 2 more shapes that we need to talk about. One is a trapezoid. Okay, so this one's kind of a historical problem. It says the Erie Canal opened in 1825 and was hailed as an engineering marvel. Below is a cross-section of the Erie Canal. Find the area of the trapezoidal cross-section. Well, for a trapezoid, we have an interesting formula. It's the hardest one that we have, and it is B1 plus B2 times H, and I'm going to divide it by 2. Okay, so the B's, they stand for bases, and the bases will always be the parallel sides of the figure. So wherever the parallel sides are, whether they are on top and bottom, or whether they are on the sides, it's the 2 parallel sides. So now we plug in our information. So our bases are 28 and 40, and it makes no difference which one you call base 1 or base 2 because we're adding them together. The height is always going to be the distance between the 2 bases. So in this case 4, and then we're going to divide that by 2. So now we just take our calculator, and the way I like to do it is 28 plus 40 equals, and get an answer to that. Then multiply it by 4 equals, and then divide it by 2. So I force my calculator to do the order of operations for me to ensure that I type everything in correctly, and I end up with 136 feet squared. So the 2 bases again are the parallel sides. The height is the distance between them. You plug that into the formula and do the math. That's all there is to a trapezoid. Okay, we have one more shape to go, and that is a circle. And you need to be able to find 2 things with a circle: the circumference, which is the distance around it, and the area, which is the space it takes up. So let's start with circumference. So if we were to go back to our formula chart, circumference is found by doing C is equal to pi d. Now remember, I told you I like to use this formula and this formula only. Okay, it just helps keep it straight for me what formula is for circumference and which one is for area. Okay, so circumference. Do I know the circumference? No, that's what I'm looking for. So C equals. Well, pi, we're going to use 3.14 for that. So 3.14 times. Now we need to understand the diameter. In this particular problem, we were given the distance from the center to the circle, and we know that that's 7. Well, that is called a radius. Well, I need to know the diameter. So if from center to the circle on this side is 7, from center to the circle on this side is also 7. So that tells me the diameter is 14. So that means all I'm going to do then is multiply pi by 14. So C then would be approximately 3.14 times 14, 43.96, in this case centimeters, just themselves, just centimeters, because we're talking about a distance around the circle. Okay, so now for area, we're going to use the formula A is equal to pi r squared. Well, again, A equals 3.14 times, and now we go back to that radius, and we know the radius is the distance from the center to the circle, and we know that that's 7. Now what I also like to do when it says r squared, I like to actually write out what that means. So I know r squared means I'm going to do 7 times 7, so I write it as 7 times 7. And then I plug it into the calculator, 3.14 times 7 times 7, and I find my area is approximately 153.86 centimeters squared, because it is an area. Now you'll notice on circumference and area, on both of those, I put that the answer was approximate. And the reason why we put that it's an approximate is because our pi is a rounded number. Pi is actually a number that continues going, but we only use the first 3 digits. So my answer then becomes an approximate value. Now what you found here is that area is nothing but just plugging information into a formula. The reason why I have you write the formula down is because it tells you what to look for in the figure. So every single time we work a problem, I want you to write the formula down. Okay? That tells you what you're looking for. Okay? If you don't know what you're looking for, you can't find the answer to the problem. So in this video, we looked at circumference of a circle, an area of triangles, rectangles and parallelograms, trapezoids, and circles. In the next video we do, it'll be talking about volume. Until next time.